Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back. We have my GCSE class here today. We are looking at the EDEXCEL 1MA01H paper, the 9th of June 2014, non-calculator. There will be one or two questions that we will have to do in a separate video, the ones which involve drawing and transformations. It's a bit difficult for me to do using the current tool set I have at the moment. So let's get started without any further delay. Right, this is the starting page and the formula page. Let's make a move. Okay, right. Okay, right. I'm going to use the mouse a bit as well. Right, answer all questions. Right, here we go. Okay, folks. Right, let's see which pen I've got. I've got a black pen. Right, let's change color. Right, work out 1/7 time by 2/3. Looks like a very baby type of question. It should be nice and straightforward. We have proper fractions that need to be multiplied. We try to cancel them diagonally. Okay, first of all, we look at the 1 and the 3. There's nothing. These are both. 3 is a prime number, 2 is a prime number, and 7 is a prime number. So if we try to cancel them, there's nothing actually that we can cancel at the moment. So we try cancelling it first, can't cancel. What do we do next? We then multiply the top numbers, and then we multiply out the bottom number if we can't cancel. Here we can't cancel vertically, or we can't cancel horizontally. Sorry, we can't cancel vertically or diagonally. So that gives us now 2/21. Now that is called a proper fraction. So there's nothing that we can do further with that. Can't cancel it down anymore. It's not top heavy anything else, and that's the answer that we put over here. Mr. Harun, grab a paper behind you, please. Right behind you, over there, and write these answers down. Okay, let's just make that one look a bit more clearer. 2/21. Now, the next question, we have 3/5 minus 1/3. Now, because we have fifths and thirds, they're not the same type of fraction, we need to make them the same. We call it making them equivalent. Okay, to make these equivalent, what we need to do is, so for example, we've got 5 and 3. The lowest common multiple is, for 5 and 3 is 15. Or one way of thinking about it is we time each bottom number by the other bottom number. So the 3, we time that by 5, top and bottom, to keep that fraction balanced. We time the 5 by the 3, top and bottom. So we should have now 9/15. If you spot a mistake, folks, please politely tell me straight away so we can correct it, because otherwise it'll go onto YouTube and it'll be bad. So we have 9/15 minus 5/15 gives us an answer of 4/15. Now, can we do anything with 4/15?
No.
So that's the final answer?
Yeah.
Okay, lovely. Put down here 4/15, and that's the end of question number 1. Okay, question number 2. Right, here are the times and minutes that 20 children took to walk to school. Okay, draw an ordered stem and leaf diagram for these times. Okay, right, let's have a look. Now, what is the lowest data value that we have here? The lowest data value is 5. Okay, now, so if it's 5, then we should really start here with a 0. Like 0, this is the tens column. 0. The next one will be something with 10 something, 20 something, 30 something, and 40 something. Oops. Oh, that's that. Now let's put a key down. So for example, we have a data value over here, for example, which is 40. So we could say, for example, here, key could be 490 represents what?
40 minutes.
40 minutes. Okay, so we're telling you this is how we read our stem and leaf diagram. Okay, so now let's have a look at all the numbers which are in place value less than 10. So for example, 0 something. So the first one, as you mentioned, Saf, can you go for it please, was 5. So 5, we would read that as 0.5, 0 tenths and 5 units, for example. So that one's done. The next one, which is less than 10, 9. So that would be read as 0.9. Okay, now we're looking at the ones in the tens now. Abdullah, give me all the numbers in the to do is starting with the 10, 1 in the tens place value. So like 10, which is the first one we got?
3.
Okay, we go for the 3, which is the 13. So that's 13 represented like that. What's next?
5.
5 because we have a 15 in there somewhere, which is here. Good. 6 for the 16 one, which is here. Good. Next. 8 for the represent the 18 because it's 1 and 8, 18. Go on. Any more?
9.
And the 9, which is 19, and we have another 19. Now, if you have two 19s, do we write the 9 twice or just leave it write it once?
Twice.
You have to write it twice. Excellent, lovely. Okay, Saf, can you do the 20 numbers for me? All the numbers starting with 20 something. Give me an order, please. So the first one would be what? 20 what? 21, then 22, 23, 23 again, 25, 27, 28, 29. Let's have a look. 21. Okay, we got our 20. That's 22. 22, 23, 23. That's those numbers there. We got our 25. That's good. It's covered. 27, and we have a 28. 28, and the last one was 29. Lovely. Okay, Rutaba, give me the numbers starting 30 something.
1.
31.
2.
32.
4.
34. Let's have a look where they are. 31, 32, 34. Now, is there any with 40 Hamza in the 40s? Just one. Yeah? So 40. That's just that one, which is the last data value here. And that's all covered. Are we happy with that stem and leaf diagram? Nice and straightforward? Yes. Yeah? Good? Okay, lovely. So let's move on to the next question. Okay, Harun, you happy there? Yeah? Okay. Okay, what we're doing today, Harun, just to fill you in because you weren't here last week. Last week we had to go this paper in the lesson. And we're now going through the model answers. Okay. Question number 3. 50 people each did one question. Let's move the paper up a bit and so make it look a bit more. That's better. I've got more space to work on. 50 people each did one activity at a sports center. Some of the people went swimming, some done squash, some done gym. Okay, so we've got 3 activities and it's between males and females. So this is going to be what kind of table we call it? A two-way table. Okay, we're going to have a two-way table. So we've got activities on one side coming down, and so let's put that in quickly. So we have here, so we're going to have squash, SQ for squash. Okay, or we can write it down full if you like. Okay, next we could do is gym. What's the other one left over?
Swimming.
Swimming. Okay, now we can have females here and the males here. Okay, right, and now we need to make a table. We're going to have some totals as well. So we'll have total for all of these. And we'll have a total for all of these as well in the columns. Now let's just quickly draw some lines on there. Okay, I think I might just do mine freehand, just make it a little bit quicker. Okay, let's see if I can do it freehand, if it's not going to be too messy. Okay, let's go. Here. So please use your rulers. I'm just trying to make it so it's done nice and quickly. And I think I'm going to use a line tool for the next one. It's a bit difficult drawing straight down. Okay, that will do. I think I've made my line slightly longer at the bottom, but that's not a problem. You need to ignore those parts. Okay, let's get back to our writing tool. Okay, all right, let's change color. Right, so it says 21 of the people were female. So the female total here should be at the end, should be 21. 20 female total at the end, yes? Now, we know that the total, the altogether, how many people are there altogether in the survey? 50. 50 goes? Okay, if I put that in the wrong place, I think I'll put it off the time. Okay, let's take rid of that. So 50 goes here. Now, if there's 21 females and the rest are males, how many males are there going to be then?
No, 29.
29 to make them add to 50. Okay. 6 of the 8 people who played squash were male. So how many people played squash? 8 people. And out of them, how many were male? 6. If you had 6 males, so how many were remaining females then? 2. So that's how we kind of infer from 1. So it says next information, 18 of the people use the gym. So the total people who use the gym is 18. 18 goes there for the gym, come down and total. 9 males went swimming. 9 males went swimming. Okay, now, you're probably thinking, how are we going to do the rest of it? Now, remember we have totals going down and totals going across. So, for example, here we have 8, add 18, add the next number will give us 50, because the total is squash. And so, what's 8 add 18? What's 8 add 18? 26. What's 50? Take away 26. 24. So, you put that in. Now, if 24 is the total for swimming and there were 9 males, how many females does that mean that there should be?
15.
15. Because 15 add 9 is 24. Now, if there's 2 people playing squash and 15 playing swimming, the females, and there's 21 females in total, that gives you 2 add 15 is 17. And what's left from 21? 4. So I fill that one in. Now, 4 add this number here. The number of females plus the number of males gives you 18. So the number of males must then be 14. Work out the number of females who use the gym. Okay. So the females who use the gym in total is 4. Oh, okay, 4 then. Okay, question number 4. Mr. Brown and his 2 children are going to London by train. An adult ticket costs £24 and a child ticket costs £12. Mr. Brown has a family rail card. Okay, so you've got some discounts here. Now, let's think about the discounts. Okay, Mr. Abdullah, if you're going to save 1/3 of an adult ticket, so how much will you pay then in terms of fraction? If you save 1/3, which means that you will then pay for 2/3. Excellent. If you save 1/3, that means you pay for 2/3. Now, okay, Mr. Saf, children's tickets are 60% off. So how much percent do you pay for them? 40%. Lovely. So this is us now understanding and interpreting the discounts. So if you have 100% to pay and 60% is forgiven, you don't have to pay it. So you got 40% left. If you have like 3/3 to pay, 1/3 is forgiven. So you got 2/3 left to pay. So this is how we're going to think of the question. Work out the total cost of the tickets when Mr. Brown uses family rail card. So Mr. Brown, first of all, let's work out Mr. Brown. Because it's Mr. Brown, we'll work in Brown. Mr. Brown. Okay. So Mr. Brown, he has to pay 2/3 of his ticket. So 2/3 of, how much is his ticket? 24. Now, how do we work out 2/3 of 24? What does that mean? Remember, it's non-calculated paper, so we can't use calculator. Can you help us, please? Everyone's quiet.
You work out 1/3 and you add the time.
That's right. So to 24, you divide it by the bottom number and times it by the top number. So 24 divided by 3 times by 2. What's 24 divided by 3?
The answer is 16.
Okay, let's just do the cancelling first.
Yes, 8.
Yeah, that's good. So divide that by 3, divide that by 3, that'll be 8. 1. So 8 times by 2 now on the top. So Mr. Brown is going to pay how much money for his ticket? £16 is Mr. Brown. Now let's look at the children. Now how many children do we have? 2. So you have 2 children. They have to pay, how much is the normal ticket? £12. So they're going to pay 40%, because that's how much he's going to pay, because you save 60%, saving, paying. Now he's going to pay 40% of 2 tickets. So a child ticket is £12. Okay, whoops. Let's undo. Okay. So what's 2 lots of 12? 24. So we're going to work out 40% of £24. Right. Mr. Saf, give me the technique for how would you go about working at 40% of something? What would you do first, second, third, go on?
10%.
Work at 10%. So if you want to work at 10% of 24, what we do, we divide by 10. Lovely, because 10% means 1/10. So 10% of 24 will give us what? 2.40, yeah? 2.4. And then now, how do you get from the 10% you just told me, how do you get up to 40?
Times by 4.
Times by 4. 10 times by 4 is 40. And 2.4 times by 4 will give us what? We happy with that? It's 9.60. Now let's go over here to the top a bit and let's change color over here. Let's go for a blue. So Mr. Brown is paying £16 for his tickets, and the children we have to pay, he has paid £9.60 for theirs. We've got to add up the adult tickets and the child tickets. Okay, so we have 6. Oh, that wasn't nice. Okay, right. Let's. Right. That's better. So 0. We got 0 take with 6. Can we do 0 take with 6?
No.
What do we do? We borrow from the. Sorry, pardon me. We're adding 0 add 6 is 6. And that thing moving around. Oh, maybe that's what it is. So 0 add 6 is. Oh, we don't want that. 6. 6 add 9 is
15.
15. Good. And that will give you. So what is his total cost? £25.60. So when you write your final answer, is there space on the bottom for the final answer? Okay, I'm not. Right, shall we? Let's see if we can just move it up a bit. So over here at the bottom, we can write down the answer. £25.
Is it £9.60 for one child?
That's for both.
Both.
Yeah, because we've done 2 times by £12 for the child tickets. Okay, are we happy with question number 4 now? Blow by blow, we happy yet? Good. Let's move on to the next question. Okay, just trying to get as much space on there as possible. Okay, let's change color. That's a bit of a depressing color there. Let's go for a nice color. Okay, blue. Rebecca wants to find out how many books people buy. She is going to use a questionnaire. Design a suitable question for Rebecca to use in her questionnaire. So, somebody from this class, please give me a nice question. Remember, the question must be very specific about what you want to ask, and you must have a time frame in there. So, who's got a question that we can write down here? So, starting with, I'll start you off.
How many books do people buy?
No, how many books do you buy? So, how many books do you buy?
Per week.
Okay, how many books do you, how many books? How many books? No. How many books? Oh, sorry, Mr. How many books do you buy? Okay, now in a week or in a month, yeah? So it's got to have a time frame on it, but you can say in a week. That's fine. Week is also good as well. A nice question mark under there. So that's the actual question. Okay, now, here comes the answer. So the answer, we need some, what do we need? What do you call them? We call them response boxes. Okay. Now, how many response boxes do we typically have per question? Roughly about 4 or 5, yeah? Okay, let's undo the last action there. Let's go back to pen. Right, okay. Right, so the first box could be what?
0.
0. You don't buy any books. The next one could be what?
1, 2, 3.
1, 2, for example, 2. Yeah? And the next one could be 3, 2.
4.
And the next one?
5, 6.
And the next one could be 7.
8.
7 plus. So 7 and above. Okay? So the person, you put a lot, tick that box. That's the question. So the question is, how many books do you buy in a week? And this is the response boxes. So 0 books, 1 to 2 books, 3 to 4 books, 5 to 6 books, or 7 plus books. And that covers every kind of eventuality that you could possibly have for answers. What do we have to make? What do we make sure that these numbers don't overlap? So we don't have like 1 to 2 and then 2 to 3, for example. Okay, are we happy with that question? Let's move down. Let's move the page up a bit. Okay, right now. We're moving the page down. We're also going to expand it a bit so we're going to have much more space. Let's make it a bit bigger. Oops, oh, I didn't want to do that. Okay. All right, I like to make this nice and big and chunky. Okay, right. There we go. That's nice and big. Can't see that? You need to go Specsavers. Okie dokie. We're on pen now, yeah? We've got a nice pen. Expand. Expand means multiply at the brackets. So whatever's outside has to be multiplied with what is inside. Oh, that looks lovely. So we have 2m multiplied by m. Also we have 2m multiplied by plus 3. Are we happy with that? That's what it means. So we are multiplying out the brackets. So 2m times by m will give us what? 2m squared. 2m times by plus 3 is? Okay, now, one thing I must emphasize here, why have I put the plus 3 in? We all know that 3 is positive anyway. But why have I put the sign with it? Because the sign gives us the sign for our answer. 2m times by plus 3 gives us plus 6m. So that tells us what to put here. If you don't put the sign in there, you might just put 2m squared and a gap and 6m, and that would be wrong. You must put the plus in there. So that's how we get our correct answer. That one's done. Are we happy with that? Yeah? Okay. The next question says factorize fully. Okay. What does the word mean fully? It means factorize until you pull out all the highest common factors until you can't factorize it anymore. Now, you have 3xy squared minus 6xy. Okay, let's go for this one. Okay. So let's split it up. So you've got 3 here and you've got a 6 here. So what's the highest common factor between 3 and 6? The highest common factor between 3 and 6 is 3 so far. We have an x here and another x over here. So the highest common factor between x and x is x. We have a y squared and a y. The highest common factor is just y. So what we're going to pull out then, after we finish, we're going to pull out 3xy. So let's now start splitting this up. So we say 3xy is same as saying 3 times by x times by y times by y minus 3 times by 2 times by x times by y. So we're splitting everything up into its factors. Now let's start circling the common factors ready for extraction. So we have, what do we say is common? We have to pull out what altogether? 3xy. Here we go. So 3xy is here and 3xy is also here. Yeah, that kind of funny sausage. Okay. So we pull that out over here, put it on the side. And what's left over now? What's left over on this side?
Y minus 1.
Just the y, copy down the minus. What's left over here?
2.
Minus 2. Are we happy with that? Are we happy that's the answer? Okay. Let's make it a bit smaller now. Go back to the side. Okay. Right. Question number 7. Okay, let's make a little bit on this side. Okay. Some more space up here, really. Okay, here we go. Question number 7 is a little star in front of it. What's that called? That's our functional skills star. The question is like putting math into context of real life. So the diagram shows the plan of a small field. Diagram not accurately drawn. What does that mean? That means don't start measuring it. Yeah, I'll start working things out from the diagram. Kevin is going to keep some pigs in the field. Each pig needs an area of 36 square meters. Work out the greatest number of pigs Kevin can keep in the field. So we are now currently on question number 7. Okay, lovely. So let's have a look. Now we need to work out the area of this shape. This composite shape. We can do it in a few different ways. We can do it by splitting into 2 shapes, adding them up, or we can do it as one big shape minus the corner that we've chopped off. So for example, if I was to complete this shape here, bring it down, and we work out the area of this part and cut it off. So that's my idea. So let's write down my idea. My idea is that we have the area of the big shape, the outer shape, minus the area of the small piece that we cut off from the corner, which is represented by this part over here. Are we happy with that idea? That's just one way of doing it. Now, Mr. Saf, I want to work at the area of the big shape. So where would I start with the area of the big shape? The big shape here is this big rectangle here. Okay, what I'm going to do, I'm going to quickly grab this tool here. I'm just going to kind of go over it. And this, so that's the outside shape. Okay, right, let's go back to pen. And then we also have the inside shape, which is this one corner over here, this rectangle there. Okay, let's just quickly change color just to hide, just to illustrate that to you. We're going to cut out the shape here. Okay, I don't know, let's give me another red one. We have an orange. Yes, lovely. Okay, pen. Right, can we see those two rectangles, the big outer red rectangle and the small orange one? Yeah, the shading in there. So the area is the big one. Okay. Area of the big one is going to be length times by, and the area of the little one is going to be also length times by. With what is the length of the big one? 16 and 10. So 16 times by 10 should give us an answer of 160. Okay, what's the small one? The measurements, we've got 7 here. So what's this going to be then? 7 add this number gives me 16. So it's going to be 9. 7 add 9 is 16. Now we've got 10 altogether as the height. That part is 6, so the missing height has to be 4. Lovely. So the length and the width is going to be, for this one, going to be 9 times by 4. 9 times by 4 is?
32, 28, 36.
36. Okay, lovely. Right, now, we got 160 minus 36 will give us what?
24.
Okay, is it? 124, yeah?
Yeah,
Okay. Thank you, Abdullah. Sorry about that. 124 what? Meters squared. Lovely. Right. Now what we need to work out? We need to work out how many of 36 meters will fit into here. Okay, let's just, I think I've done that a bit too much. Okay, that's better. 36. Now, so the next calculation is 124 divided by 36. Right, any ideas on how we can cancel this down, or we can work this out without using calculator? What technique would we use? So we would divide them both by, divided by 2, anything bigger than 2? Any ideas? Any number we try which is bigger than 2?
3.
Divided by 4, for example. Yeah. So if you divide this one by 4, 36 divided by 4 is 124 divided by, we divided by 3. 124, so 36, we divided by 4, isn't it? Yeah. So divide by 4, top and bottom. So 4 times by 9 is 36. So how many 4s in 124? Any ideas? That'll give you 31. Lovely. So we have now 31 divided by 9. So how many 9s going to 31?
3.
Remainder?
4.
So according to our calculation, Kevin can keep 3 and 4/9 of a pig in that area. So can somebody tell me what's wrong with the answer? You can't have a fraction of a pig. So it's got to now, do we round it up or round it down now for common sense? We have to round it down because he hasn't got enough space for the 4th pig. So he'll have to be only keep 3. He'll have a bit of extra land. So the final answer for this question is he can only keep 3 pigs in that particular farm. That space. Okay? Are we happy? Good. Right. Okay, should we move on to the next question? Okay, the next question, we're going to have to do that on the visualizer. We'll come back to that one. Okay, let's make the a bit smaller. And same for the transformation question as well. Okay, we're going to skip. And this next one is enlargement. Again, I'd rather do that on the visualizer. It'd be easier than doing it on the computer. Okay, let's move on to question number 10. Number 10's also got a little star next to it. Okay, milk is sold in 2 sizes of bottle. A 4-pint bottle costs £1.18. A 6-pint bottle of milk costs £1.74. Which bottle of milk is the best value for money? So let's write it down, the information we have here. So 4 pints cost us 118 pence. We have 6 pints. That costs us 174 pence. Just changing into pence. Hopefully that should help us a bit. Now, we need to work out, okay, Mr. Saab, what we're trying to work out here, we're trying to work out which one's got the lowest price per pint. So we started with 4 points, but we need to work out what is the unitary cost. What is the cost of 1 point? Now, how do we get from 4 to 1? Divide by 4. Lovely. 4 divided by 4 is 1. What we do on the left hand side, we have to do on the right hand side. So you have 118 divided by 4. Ladies, any answers on that? What do you get for that?
For that one, I got 0.295.
Okay, you changed it back into pounds.
Yeah, it was always pounds.
Oh, you left yours in pounds. That's okay.
So it's 29.5.
Lovely. Thank you. So that one is 29.5p per pint. The next question. We're going to go from 6 points to work out the cost of 1 point. So we have to now divide it by 6, both sides. So 174 divided by 6. What's 174 divided by 6?
29.
So which one is cheaper? The 4-point bottle, the 4.1 or the 6.1? The 6.1 is cheaper by half a p a litre. So the answer is going to be which bottle? So we got to make a statement now. Should we say the 6 point? They're written as bottle anyway. So 6-point bottle is the best value for money. Okay, as it is 0.5p cheaper per litre. Just a bit of extra bit. Okay, are we happy with that? So we've
Cheaper per pint. Cheaper per pint.
sorry, thank you. So it's not litre. Thank you very much. Let's see if we can do that. Oh yeah, very good. Okay, lovely. Are we happy with that question? Nice and you gone. You need to copy that up? Okay. Nice and straightforward ratio question. Are we happy with that, Harun? Good. So we didn't have to do any complicated calculations or stuff, which giving us a nice answer there. So have you got it all down? Okay, ladies, ready to move on?
Yeah, I've got it.
Okay, try a couple of the persons and see next to you if they've got it down. I need to move on to the next question now. Okay, here we go. Right. So, are you okay there? Happy, yeah? Right, question number 11. ABCDE is a regular pentagon. And the keyword here is? What's the keyword? Regular. What does the word regular mean? It means all the lengths are equal in length. All the internal angles will also then be equal. So that gives us an idea of the length and angles being equal. So it says BCF and EDF are straight lines. Work out the size of angle CFD. So CFD is C, here's C, here's FD. So they want you to work out this angle here. This angle is called CFD. I don't put a line on top to indicate that I'm looking at the angle there. Right. Have they given you any angles already to work from? No. So we need to go back to some basic principles. So let's have a look. What do we know about polygons? Now, let's have a look. If I know, for example, this angle here, it's going to be the same as that one there as well, which is the same as all of these in here. Okay, so all of these angles are all the same. So if I can work out what this angle here is, I'll know that one. Once we know this one, then we can very easily work out, that one. Is that right? Once we know the green ones, then we can quite quickly then work out the orange angle, which is the one we want to work out. So we're going to start here. So first step is work out this, then work out that, and then work out this. So let's go for that then. So let's try and keep the color code running. So we had that one. So how do we work out one internal angle of a regular polygon? What formula do we use? We use the formula n minus 2 time by 180 divided by n. That's one way of doing it. Not the only way of doing it, is one way of doing it. Where n is the number of sides. How many sides does a regular pentagon have? 5. So n in this instance has a value of 5. So we have to substitute 5 into here and into there as well. So let's put them in now and work it out. So we have 5 minus 2 time by 180, and then we have to divide it all by 5. Now 5 minus 2 will give us an answer of 3. 3 times by 180 will give us an answer of 540. 540, then divided by 540, then divide that by the 5 to work out what each one is. 108. So we have now worked out the first part of the puzzle, that each one of these angles is 108. Now that we know the 108 one, we can work out the green angle. Now, what information do we use for working out the green angle? What maths do we know? We say angles. Okay, who's going to give me the definition? Now, remember there's the incorrect definition and there's the correct definition. The difference is literally a few words, a few letters.
Angles
At a point. That's the key word. Angles at a point. Not angles on a straight line. That is just wrong. It's not angles on a straight line. It's angles at a point on a straight line. So write that down. Angles at a point on a straight line add up to 180 degrees. Okay, so which ones are we talking about? So the angles at point C, i.e. at point C and point D in brackets. So we're talking about here. So what I'm going to do now, I'm going to go over in a line. Let's get a line, and yeah, that looks good. So I'm going to go over in the line so you can see what I'm talking about. So that line there. I'll do this line slightly off the main line there. That's another line here. Okay, let's go to a pen. And yeah, we've got green. So we're talking about this point here and that point there. Lovely. So let's make some few statements. I'm going to quickly change to a black here now. So we're still working on the green part here. So what we can say is 108 add. Okay, now the green angle. So the green angle, if you define the green angle here, what's that going to be called? Oh, I didn't want to do that really. That green angle, how do you label that green angle? It's angle DE, DCF. So DCF is in the middle. This one's going to be what? CDF. Just to give it some. Whoa. Okay. CDF. So 108 degrees add angle DCF is equal to 180. Therefore, angle DCF is equal to what? 180 minus 108, which will give us 72. Similarly, 108 degrees at point D now. So that's going to be CDF, we said, at angle CDF. That's also equal to 180 because angles at a point in a straight line equals 180. Therefore, CDF, you want to rearrange the equation to work it out. Opposite of adding 108 is minus 108. That is also 72. So if you want to, we can go over this part now in green. Okay, I'm having difficulty going over in green. What I mean here, that's the next best thing we can do. Circle it. So I'm going to put in here now. Oh, it doesn't like that. Okay, do you know what it's trying to select things? Okay, we'll just write 72 over here and point to it. I think that's the best thing to do. Any technical issues with the software. Software is going crazy on us. Okay, right. So angle CFD now. So this. So what do we say now? So in triangle, what triangle do we have?
Isosceles.
Yes, our isosceles triangle. In triangle CFD. In triangle CFD, angle. Whoops. Angle. Okay, angle CFD. Now remember, it's a triangle. This angle definition means the middle angle is the F part is equal to. How do we work it out? So we say, what do we know about triangles? What's the angle sum? So angle CFD is equal to 72 plus 72 plus the. Okay. Right. I don't know. I've labeled my diagram slightly wrong. Pardon me for a second. Let me rub this off. Just this should be on this side. Should be 180. Are we happy with that, folks? So 180 is equal to, sorry. So all of these three angles, DCF and CDF and CFD, should all add up to 180, because the internal angle sum of the triangle is 180. So now we can quite quickly and easily work out CFD. Now CFD, opposite of adding 72 is minus 72. Opposite adding 72 is minus 72. What's 180 minus 2 loss of 72?
Minus 144.
So it's 180 minus 144, which will give us an answer of 36 degrees. So is that our final answer? Yes, it is. So that's our final answer for that question. So we can say quite comfortably that the answer is 36 degrees. And that's our mathematical explanation. So we've made a statement here about the equal to 180. We've labeled the 72s. Okay. Are we ready? Are we ready to move on to question number 12? Okay, you can change temperatures from degrees Fahrenheit to degrees centigrade by using the formula centigrade equals 5 times by Fahrenheit minus 32 divided by 9. F is the temperature in Fahrenheit, C is the temperature in degrees. The minimum temperature in an elderly person's home should be 20 degrees centigrade. Mrs. Smith is an elderly person. The temperature in Mrs. Smith's home is 77 degrees Fahrenheit. Decide whether or not the temperature in Mrs. Smith's home is lower than the minimum temperature should be. So decide whether or not the temperature is lower. Okay, let's have a look. Now, what is the temperature in Fahrenheit? It is 77. We need to put this 77 into 4F. So if you write down the formula, C is equal to 5. Now where we see the F, you put in the 77 minus 32, close the bracket, divided by 9. Okay. Right. What's 77 minus 32?
45.
We'll give you 45. So we have 5 times by 45 divided by 9. Now, can we do any level of cancelling here? Is there anything we can cancel? 45 and 9. 9 divided by 9 is 1. 45 divided by 9 is 5. So C is then equal to what? 5 times by 5, which is 25. Divided by 1. 25 divided by 1 will give us an answer of 25 degrees centigrade. Okay, now we have to decide, is the temperature lower? And the answer to that is no. The temperature is not lower than 20 degrees. It is higher. It's actually 25 degrees. Okay, are we happy with the explanation there, yeah? Staff, you okay with that? Right, let's move it up to get the next question in. Whoops, too much there. Right, let's make it a bit bigger. Need some more space. Move around a bit. Wow, that looks more nice. Let's go to the top part there. Lovely. Okay, right. I've got the full screen to concentrate on that question. So it goes, make F the subject of the formula. Let me just rewrite it again over here, folks. So C is equal to 5. There's a little baby invisible times. And then it's F minus 32. All of that divided by 9. Now, in order for us to rearrange this correctly and accurately, correctly and quickly in the test, we need to understand the basic principles. So, how do we start the question, Mr. Saf?
Take the number with the.
Whoa! We start by looking at the letter one of the list. We start at the F that we want to make the subject, and then what do? We identify the actions. So F is first of all been minus by 32. We call this the first action. It has then been times by 5, which is called the second action, and then it's been divided by 9, which is the third action. Okay, first action, second action. So write down here first, second action, and third action. Now, once we've labeled what's actually happening to the F, we now need to solve it by doing them in the same order that we've labeled them, or in reverse order. We always do in reverse. Whenever you solve, we do in reverse order. So let's get so opposite of divide by 9 is times by 9. So in the next line down we have, what do we have? 9C is equal to 5 bracket F minus 32. Okay, the next bit. Yeah, opposite now, time by 5 is divide by 5. We'll have now 9C divided by 5. Once the multiplier of 5 goes, the brackets also go. So we don't need them anymore. Okay, the next bit and the last bit, what we do now?
Minus 32 goes over.
That's why the minus 32, that's the last thing to move over. It becomes a
Plus 32.
plus 32. Now, this is very important. There's a lot of mistakes are made by students. I'll write down what the mistake is first. Okay, so this is the wrong way of doing it. I'll do it on the side. And I'll label it the wrong way of doing it. Okay, normally students do, oh yes, 9C add 32 divided by 5. Now, why is that the wrong way of interpreting 9C over 5 plus 32? Why is that wrong? Abdullah, why do you think that's wrong? Because it looks, well, I intended to do 9C over 5 add 32. And when you read it, it says 9C plus 32 divided by 5. What's wrong about it?
Isn't the 32 meant to be plus?
Plus 32 is meant to be? Separate. Lovely. So on this line here, we're going to have 9C over 5 as they were originally, and then separately plus 32 will give us the F that we're looking for. Okay? Right. So are we happy with the answer? Yeah? So we start at the letter that we want, we identify the action, then we remove the action or solve by moving the action in reverse order, and be careful as we do it. Okay, we are now ready. Is there any more parts of that question? No? Next question. Okay, let's make it smaller. It's too big. Okay. Okay, this is question number 13. I'm going to relabel it because we just about lost the question number. Question number 13. Okay, right, let's have a look. It says a competition, a prize every 2014 seconds. In a competition, a prize is won every 2014. Okay, folks, after you finish this question, we'll have a break, okay? I can see in the looks on your faces. Looks like you're about to pass out. A prize is won every 2014 seconds. Work out, and now here's the key word. Work out an estimate. Estimate is not another word for guesstimate. So they don't want to just guess numbers and just make things up. but we have to use mathematical rounding techniques for the number of prizes won in 24 hours. Now, we need to change 24 hours, we need to convert that into seconds to see how many of these fit into that. Because every 2014 somebody wins the prize. So how many seconds are there in a day? So, first of all, we turn hours into minutes by multiplying it by 60. 24 hours times by 60 will tell you the number of minutes. And then we multiply it again by another 60 to change those minutes into seconds. And then if you want to work out how many prizes, so you have to divide it all by 2014. Now, that's a calculation that I wouldn't want to do. I don't know my 2014 times table. Yeah, I don't divide by 2014, it's not cancelled like crazy. So, the key word here is, what's the key word? Estimate, which means here is code for rounding. So let's start rounding some of these figures off. Now 24, we're going to round that to the nearest 10. These are fine because they're already rounded to the nearest 10. 2014, it's a nice big number. We're going to round that to the nearest 1,000. So it's already in the thousands. Keep it nice and I'll call this my chunky numbers. Keep the numbers nice and chunky. So it's easy to work with. So 24, what does 24 become? 20. 60 stays as 60. 60 stays as 60. 2014 becomes 2000. Now all of a sudden the question looks much more nicer. Chunky numbers, big numbers, easy to deal with like tens and hundreds. So we're going to start cancelling. So divide that by 10, divide that by 10. Divide that by 10, divide that by 10. Divide that by 10, divide that by 10. Already the question is looking nice. Now we've got divide that by, whoa, oops. Okay. Divide that by 2, divide that by 2. So what we got left now on the top? So 1 times by 6 times by 6, which is 36. So my estimate for the number of prizes won in 24 hours is 36. In the mark scheme, you are allowed an answer between the range of 35 and... So as long as you get an answer, your answer, don't forget, people will do, someone will round up to the nearest maybe 10. You could round up slightly differently as well, especially the 2004 in the bottom. But anything between 35 and 50 with the proper calculation, that is the examiner's little note here that you got for you. So as long as you're in that range, so we are happy with that. Okay, I'm just going to pause it now, and to pause it, what do we do? Press.
Can you computer, sir?
Okay, folks, welcome back. We've had this whole break. Question number 14. Now, Emily is driving in France. In France. Okay, she sees this sign. Remis, I think, Dijon, Lyon. Emily is going to drive to Dijon. Try my French accent now. She plans to drive at an average speed of 50 miles per hour. Work out how long it should take Emily to drive to Dijon. Okay. Now let's have a look over here. In this little... So Dijon is how many kilometers? 480 kilometers. And she is driving at a speed of 50 miles per hour, not kilometers per hour. So here we have a difference of units. Okay. So what we need to do, first of all, see how do we convert kilometers and miles. So let's have a look. Now, does anybody remember the identity that starts something like this? It starts off 5 miles is equal to 8 kilometers. Lovely. Now, that's an identity that we've learned in secondary school. Let's see what that means. That means when we're changing from miles to kilometers, what do? We divide by 5 and then time by 8. And when we do the opposite, we are dividing by 8 and timesing by 5. So this is kind of like a unique type of identity where we're doing so much kind of like calculations in one. Normally it's like time by 1,000, divide by 1,000 and such like that. Okay, so we want to work out how long. Now, does anybody remember the speed formula? So what do we say? We say some donkeys talk. That's why we memorize it. So we can actually make a triangle there, can't we? Cool. Oh. Yeah. Oh.
Looks like a mountain.
Okay, there we go. So, speed, distance, time. We want to work out the time, so we cover up the time with our finger. That's our fingernail. Cover it up. So that's telling us time is equal to distance divided by speed. But we've got to get the units consistent. We've got kilometers here, and we've got miles here. So that's not helping at the moment. So we need to change. So let's change, for example, kilometers into miles first. So we're going to change up here 480 kilometers into miles first before we start using the formula. So can somebody remind me? Kilometers to miles, what do we do? What do we do? Kilometers to miles is here. What is that? So we have to first of all divide by 8 and then time by 5. So we have 480 divided by 8 times by 5. What's 480 divided by 8? Anybody? That will give us 60. And 60 times by 5 will give us 300 miles. So now the distance is 300 miles converted. Okay. You don't need to put the units in there. I'm just putting for emphasis. So 50 miles per hour. Okay, we don't normally put the units. I'm just putting them there just for emphasis. The units are consistent now. So they are both the same. So we have now 300 divided by 50. So divide that by 10, divide that by 10. 30 divided by 5 gives us an answer of. So how long will it take Emily to drive to Dijon?
6 hours.
6 hours. Are we happy with that? Yeah? Good. Lovely. Let's move on to the next question. Let's make it a bit smaller. It's just getting a bit too big. Okay, I think that's round about the right size that we need. Okay, now. Let's work out the missing. Complete the table of values for y is equal to x squared minus 2x minus 1. So, x squared. X is minus 1. What's minus 1 squared? Minus 1 squared.
2.
Minus 1 squared is 1. Tired for these students, isn't it? Minus 1 squared is 1. Okay. And then we have minus 2 times by minus 1. That gives you? Minus 2 times by minus 1 will give us?
2.
Plus 2. Thank you. Then we have a minus 1. So that'll give you 1 at 2 is 3. 3 take away 1. Now don't rush your answers just in case, you know, it's a really tough question.
2.
So that'll give us 2.
That's what I was meant to say every day.
Okay, now let's put 0 now into the formula. 0 squared is?
0.
0. Minus 2 times by 0 is?
0.
And then minus 1. What's 0 minus 0 minus 1?
Minus 1.
Minus 1. Now put 3 into there. So 3 squared is? 9. Minus 2 times by 3 is?
Minus 3.
Minus 6. And then minus 1. So we've got 9 minus 6 minus 1, which will give us an answer of?
2.
2. So put 4 in there now. 4 squared is? 16. 4 squared is 7.
No, it says that.
Minus 2 times by 4 will give us?
Minus 8.
Minus 8 and then minus 1. So we have 16 minus 8 minus 1 is 16 minus 9. That will give us an answer of?
7.
Lovely. So now we've got to put those points on there. I'm not very good at drawing graphs at all with the equipment I have at the moment. So I'm going to have to kind of really try my best here. Let's just see how it goes. Okay, let's make the dots a bit more. Okay, a bit more flat. Nice big chunky dots. Okay, so now we need to plot the points. Minus 2 is 7. So minus 2 is 7. Go to minus 2, we go up to 7. And put a dot here. Oh yeah, that's nice big chunky dot. I like that. Minus 1, it will go up to 2. 0 is equal to? Okay, please forgive me for any inaccuracies in my kind of putting the points on. I'm using this kind of electronic equipment here and software, so but you guys, when you're doing it on your paper, it should be more accurate. So, sorry, I'm making excuses. 1 should be minus 2. 2 should be minus 1. 3 should be 2 and 4 should be 7. So these are your points. Okay, so you should get a nice curve going through those points. Okay, I don't know if I should even try doing this. This is going to be scary.
Can I try?
Yeah, I've been doing this, using this pad for so many months, and
Yeah.
that is.
You should, what you do, yeah, you know, with them lines, you just straight line, and then like just don't and then don't use a straight line for the bottom bit.
He's done it now.
Listen to me.
Bottom bit the best.
Okay, folks. Apologies for the. Apologies, folks. Whoa. Okay, for this, I just struggling. Please, apologies for this kind of. It's supposed to be a nice smooth curve, folks. It's supposed to be parabola. If I had a piece of paper, it'd be much easier. Apologies, folks. Right, next question. Let's move on to the next part. It says here now solve x squared minus 2x minus 1 equals x plus 3. Now, normally x squared minus 2x minus 1 is equal to what? Y. And so the y has now been replaced by x plus 3. So what they were trying to do here, we're trying to say where one graph intersects another graph. So we now need to draw x plus 3. That we should be able to do quite nicely. Okay, x plus 3. Can somebody tell us some values for x plus 3? Let's do over here.
0, 3.
Give me 1 second. Well, I'll go to 2 points. Okay, let me change color over here. Okay, now we're going to do the y values for x plus 3 now. We need. Okay, so when x is equal to, for example, minus 2, what's minus 2 add 3? 1. Okay, if when x is equal to 0, 0 add 3 is 3. Okay, when x is equal to 3, 3 add 3 is 3 add 3 is 4. You guys are clever.
3 and 3 is 6.
Yeah, I just said 3 add 3, somebody said 4. Okay, are we happy with those 3 values now? So let's plot those 3 values. So minus 2 is 1. Minus 2 is 1. Okay, 0 is 3. 0 is 3 and 3 is 6.
Yeah, sure.
Okay, now what we need to do, we need to draw a straight line through those 3 points. I have my little straight line tool here to help us. Okay, I'm going to start here. Whoa. Wow, that's looking nice. Yeah, we can do straight lines. Straight lines we can do. Right, there's my straight line. I'm going to label it up now. So this yellow kind of really kind of lovely looking parabola is y is equal to x squared minus 2x minus 1. This red line here is equal to y is equal to, what is it? X plus 3. So we draw that second line quite easily. Now we need to find out whether the quadratic equation is equal to the linear equation. Now what that means is where they intersect each other, where they cross each other. And we should be able to work that out quite easily. Let's change color here now. Let's go for a nice blue. Let's go for a line. So where do they seem to cross? They seem to cross?
Minus 1 and 3.
Oh, what was that? Oh, what am I doing? Okay. Oh, all right. Okay, let's start again. Okay, they seem to cross here. Okay, that's the first point of intersection. Okay, I think it's best if I use this one tool instead. And the second point of intersection is. Okay, I'm just going to have to start a bit here. Four. And then I can make this one bigger. Lovely. Okay, can we see that then, folks? Can we see what we just done there? So we have got now 2 answers. Let's go back to our pen. Okay, and put a. Whoa. So what is the values of the intersect on? What values is it? 80s? So what is the solution to this question?
X equals minus 1, x equals 4.
Put your hands up quietly, please, if you've managed to get x equals minus 1 and x is equal to +4 for the solutions to that particular. Put your hands up. 1. Okay. Wow. Okay. What question are we on now? Okay. Lovely. Okay, now that's nice.
Yeah, I got that.
Done that?
Yeah.
Yeah, but you did. Okay, question number 16. Colin took a sample of 80 football players. He recorded the total distance in kilometers each player ran in the first half of the matches on Saturday. Colin drew this box plot for his results. Work out the interquartile range. Let's quickly go over the main features of a box plot. So let's choose a nice color. Let's go slightly thinner. Is that thin enough? No, not nothing too fine. Okay, this one here, this value here, what's this line stand for? That is the lowest value. That's the highest data value. Wow. Whoa. Whoa.
So what are you moving then?
Highest value. Okay, this line here represents what?
Median.
It's the median. You see, writings look like horror writing. Yeah, empire. Okay, next one we have this one here, this line here. That's going to be the lower quartile. And this line here represents the upper quartile. We'll work out the interquartile range. Interquartile range is the upper quartile value minus the lower quartile value. Now, what is the upper quartile value? Okay, can somebody tell me what the upper quartile value is? The upper quartile value is here, this line here.
5.5.
5.6.
Okay, so
5.5?
No, it's 5.6. Because it's going up in 2 boxes and 2 boxes.
well done, well spotted. It's 5.6 minus the lower quartile value, which is this one here.
4.85.
So the lower quartile value is 4.85, absolutely beautifully correct. Okay, I could have done it better myself. So that will give us a total of, what's the answer?
0.75.
0.75 is absolutely correct. Well done, thank you for that, Rotava.
Oh, somebody.
Okay, there were 80 players in Colin's sample. Work out the number of players who ran a distance of more than 5.6 kilometers. Now, 5.6 kilometers is the upper quartile value, isn't it? So now, remember this, it's called the upper quartile because it's how many quarters are there?
What?
1 quarter. So 1/4 of the data value. So we have 1/4 of all the data values. How many data values do we have?
60.
How many data values do we have?
60. 80.
80.
Oh,
So we got to work out 1/4 of the 80 because that's what. So this part here represents 1/4 of the data values. Okay, so this part here represents 1/4 of the data value. The data value was 80. You see from here, can you see that 80 there? Can you see it?
You're moving the whole thing.
Yes, see? Something I'm not using to my advantage now. So 1/4 of 80 will be 80 divided by 4. That will give us a lovely answer of 20. Beautiful. Okay, now we need to move the page up a bit. Okay, question 16 part C. He said compare the distribution of the distances run in the first half with the distribution of the distances run in the second half. Now, we've done this kind of questions before. Now, we need to make a comparison, one using the median and one using the spread. Okay, so what is the first comparison we can make? Okay, anybody want to start this question rolling, please?
First of the high and median.
So, the first half. So we can say in the first half, what was this called? Total. The first half had a what? Had a higher?
Median.
Had a higher median. Higher. Median what? Median. What is the median? What's the value? Is median distance ran by a player. Median distance. Okay. Ran in the okay. First half had a higher median distance run. Okay. What about the? Now we're looking at the spread. Now, if you look over here, the lower quartile, upper quartile is over here, and this one, the lower quartile, upper quartile is lower down. What's that telling us about the first half? So in the first half,
it goes
the football players consistently
play
ran for a longer
time.
distance than the second half.
Consecutive.
Obviously, second half they were tired. They're more tired. So we can tell that why, because the actual box is higher up. the box is roughly the same size. So you can tell that most of the 50% of the data was higher up, 50% of the data lower down. So let's write that down. Okay, let's move it up a bit. Let's change color for the second part. So in the second half, the players consistently ran, okay, smaller total distance than the first half. So that's our comment on what we can see about the actual physical positioning of the actual box itself. The box in the first half is higher up. Where did it start? It started at 4.85 and it finished at 5.6, whereas this one started lower down and finished at 5.15, I think it is. That's right. Are we happy with that? So that's our interpreting the data. Okay. Good. Are we ready for the next question?
No.
No, not yet. Oh, it's still there. Okay, let's quickly copy that down. Come on, girls, let's focus on the question. So the comparison is a comparison of the measure spread and the medians. And we do in context of the question. And we could say here, just a little bit extra notes here, i.e. players were more tired and their performance had been reduced by the what's it called, second half. Okay, everything in context of what we're actually talking about. So we made a statement and we kind of explained it as well. Okay, Fira, have you got that down?
Yeah.
You sure?
Yeah.
Even the last comment I just wrote down, which I can see that you haven't put pen down to paper yet.
Yeah. So there's.
It's got special skills that girl has. Okay, right. Are we ready to move on?
Yeah.
Good. Wow. Okay. Right, it says write down the value of 10 to the power of 0. Any number to the power of 0 gives us an answer of 1. Okay, 10 to the power of minus 2. What does the minus mean? Okay, I think we need to make it slightly bigger. It might be having bigger. Okay, let's move it up again. Whoa. Okay, that's gone a bit. Okay, folks, tell me, shall I make it a little bit more bigger?
No, it's fine.
You sure? That's not more nicer now? Okay, anything to the power of minus 2. What does minus 2 mean, Mr. Saf? Minus means reciprocal, means turn upside down. 10 to the power of minus 2 means 1 over 10 squared. The minus means turn the number upside down. That's what it means. Once you've done that, the minus is gone. It's done its job. It's telling you to do something. So 10 to the minus 2 is another way of writing 1 over 10 squared. There's no minus in 1 over 10 squared. Okay, now, what's 1 over 10 squared? That's the same as saying 1 over 100, because 10 squared is 100. So we can leave the answer like that. That is perfectly fine mathematically. Or if you want to you could write down 0.01. So I'll put that in brackets here as that's just the two ways that you can write that same answer. Both answers are perfectly acceptable, okay, in the mark scheme. It says that write these numbers in order of size. Start with the smallest number. Okay, let's make this little bit bigger. And a bit more bigger. Bigger is nice. You can see them. Oh, that's lovely. And just for the little bit of extraness, just make a little bit more bigger. And that's looking beautiful. Okay, right. We need to write these numbers down. 2.73 times by 10 to the 3. What will that look like? So this first number will look like this. 273. So part of 3 means 1, 2, 3. So we'll have 273. How many zeros?
1.
1. 27.3 times by 10 to minus 3 means what? Okay, I think my pen is going too fat. It means go 1, 2, 3 to the left. So that will give us what kind of answer? 0.0273. Let's write that over here. Okay, 0.0273. Okay, out of those two numbers, which one is the biggest?
It's the last one, isn't it? No way.
Well, okay, next one. So we have 273 times by 10 squared, which means 273 times by 100, which is equal to? Okay, so let's put these numbers in the right place. 0 goes here, 0 goes here, 3 goes there. So I'm just trying to place the numbers in the same place value. So I've written up there now. The next one that's already been done for us. Okay, now is the time, the moment of truth. We need to number them. Let's put them in order of size. Okay, which is the smallest number?
The last one.
The last one. Lovely. Which is the next? Which is the next number? Which is smallest?
The second one. No, the third one.
So this one is the first smallest. Then is that one, and then after the no
That one is the third one. And
is it the first one? Yeah.
It's the third one. Then it's the first one.
And that one is the. So this one is that the third one?
Yeah.
And that one is the. Now, it says write these numbers order size. Start with the smallest first. Now, one mistake that students make is they use these numbers over here. This is my working out.
No, you meant to use the.
You meant to use the original values, which are in bold black print. So let's now do that. So now let's do the answer. So the smallest number is 273. And what's the next one?
Then it's 27.3 times 10 plus minus 3.
And then
it's 2.73 times 10 to the power 3.
and last but not least.
273 times 10 to the power 3.
Okay, and for good measure, underline it all, and that's my answer. We give the answers like the way they're giving us the answers. They put them in a list of 4, no commas in the answer. We give the answer in the same format back, and that is how you answer that question. You can also write them in a list as well. Is that okay? That's not a problem. Okay, let's get back to our normal size. That is way too big. Okay, right. Now the next question, question number 18. Solve the simultaneous equation. Who's feeling up for this? Mr. Saab, you do it for homework. Done? Good. Okay, what was your answer? X equals?
7
And Y equals?
minus 3.
Right. Lovely.
Oh,
Okay, yeah, of course. Yeah.
look at that pretty.
Yeah.
She's so happy.
Okay, let's make it a little bit bigger, a little bit. Okay, I think that's big enough. Can we all see that clearly, folks? Nice and clear? Okay, now, Mr. Harun, how would we attempt this question? We need to eliminate either X or Y. So, which one should we eliminate? Give me the easiest one to eliminate. Okay, the Y will probably be a bit easier because they're already opposite signs. Yeah? Yeah, so we're gonna choose the Y's for elimination, and we're gonna do that by multiplying the top equation by 3. We'll soon find out what happens there. So 4x plus y equals 25, we times it by 3, that gives us 12x plus 3y is equal to 25. Let's copy the original question underneath.
75.
Pardon me. Thank you. I forgot to multiply. Well, turn the whole thing off. Okay, let's try that again. So that gives us 12. Oh, I want red. Okay. And we can delete that. Pardon me, folks. We have 12x plus 3y. I forgot to multiply the 25, folks. Thank you for reminding me, Taba. That gives us 75. Lovely. Let's put the second equation back down. So we have under that x minus 3y is equal to 16. Now, can you now see my intention behind multiplying the top number by 3? What's happened now is made the y coefficients, they now become opposite. Okay, I don't know what's going on there. But I want to move it. Okay, now, if the coefficients are opposite, how do we eliminate them? We eliminate them by adding. So 12x add x will give us. Now 3y add minus 3y is going to do the proper job of getting rid of the y's. That gives us 0y, which we don't write down. So 75 add 16 will give us what?
19.
Now, what do we need to do? We need to work out the value of x. So we say opposite of time by 13 is divide by 13. So Saf, what do you get for that? What is 91 divided by 13? 7. Well done. Now, once we work out the value of x, we need to substitute it back in to work out the value of y. So let's go back to one of the, which equation should we use? We use the first equation?
Second.
You'd be better off using the first one because the second one, then y is negative. So you can't use both, but I'm going to use the first one because it's easier to use the first one. Now, ladies, where do we put the x equals 7 into? There. So we have now 4 times by 7. Add y is equal to 25. 4 times by 7 is equal to 28. 28. Add the y value is equal to 25. We need to work out the value of y. Opposite of adding, remember it's add 28. Opposite adding 28 is minus 28. So then y gives us an answer of minus 3. So Ifra, so the x value is equal to, and the y value is equal to minus 3. Job done. Nice straightforward question. Okay, question number 18. You will go back 15 minutes for the lesson. We'll try to get as much done as possible. Will you move to the next question?
No.
Yeah? Yeah. Okay, right. Okay, question number 19. Okay, question number 19. The diagram shows a straight line drawn on a grid. Line 1. A straight line L2 is parallel to the straight line L1. And the keyword here, Abdullah, is keyword parallel. What does parallel mean in a straight line context? It means that their somethings are the same. What? Something? Their gradients are the same. Well done. Excellent answer there. Very clever, class. And passes through the point 0, -5. Okay, find an equation of the straight line L2. Now, we need to first of all work out the gradient of this line here. So let's get a straight line tool. So we need to find out, make a triangle. Drawing a triangle under the line, any size triangle, but ideally one that goes through the corners. I'll show you what I mean by that. So ideally you want to make sure, I wanted the pen. Oops. I wanted a. Okay, so what I'm trying to say here, you're trying to go through points, ladies, to make the triangle which are actually going intersecting exact corners. Okay, exact. So that gives us now. Let's have a look. So on the bottom of the, how many numbers we have on the bottom? We have
6.
6. From 0 to 6, the bottom displacement is 6. And what's the height? Goes from 3 to 6, it is 3. If you want to work out the gradient of line 1, we call the M1. The gradient is equal to the height divided by the base. This is the height of the triangle, that's the base of the triangle. So it's going to be 3 divided by 6, which is equal to a half. So the gradient of line 1 is equal to a half. What is the gradient of line 2? It is also a half, because the lines are parallel. So we can say M1 is equal to M2. That's by default, because they're parallel. Now, we know that it passes through this point here. So we have a little equation. Y minus Y1 is equal to M times by X minus X1. What is that X and what's those values? So Y1 is where? Y1 is here. And where is X1? Here. This is the coordinate that they're giving us. So this point here is referring to the Y coordinate and the X coordinate given in the question. And that big Y and that big X, we leave it as it is. There's no substitution in there. These numbers need to be substituted into where I've just pointed. So just to make it a bit more clearer. So this number here, 0, will go into here. So a different color. And this minus 5 here will go into there. Are we happy with that, folks?
Mm-hmm.
Good. Let's do that now. So we say Y minus Y1. What's Y1?
5
Minus 5. So Y minus 5. The gradient. What's the gradient? What is it again?
half.
A half. Time by X stays as is. And the little minus X1. What's X1 here?
0.
0. So what's Y minus 5? 2 minuses become a?
Plus.
A big hairy plus. Okay. Now what's X minus nothing?
No.
No, this is X, not no. Okay.
It's nothing.
So that will give us now Y add 5 is equal to half time by X minus nothing is just X. Half time by X is X over 2. Now we need to make Y the subject because a straight line equation. Normally we start with Y equals something X. So let's move the plus 5 over. So we can say therefore Y is equal to X over 2 minus 5, not on top of it, but separate from it. We can write like that. We can separate. We can rewrite it as like this as well. Leave the half separate. So that is any one of those is still mathematically correct. And the answer can go here. Okay, so the answer is Y is equal to half X minus 5 for that question. Are we happy with that, folks? Yeah? Happy? We hushy, yeah? Okay, right, let's move this question to this side now. Okay. How many questions got left? Few.
So many.
What do you mean so many?
Like
6.
6 questions left.
parts in it as well.
With the A, part B, part C.
Okay, we will try our best.
7 pages.
I think we'll finish probably question 20 and I'll do the rest later, inshallah. Okay, yeah.
You can't limit to Sunday now.
No, this is something at the moment because. We'll see. Maybe we can possibly play. We'll see. Okay, Steve has a photo and a rectangular piece of card. The photo is 16 by 10, which you can see here. The card is 30 by 15. Remember that one?
No, I didn't.
No, okay, no problem. Steve cuts the card along the dotted line shown in the diagram below. So he cuts off X. Steve throws away the piece of card that is 15 by X. The piece of card he has left is mathematically similar to the photo. Work out the value of X. Okay, right. So this part here, what color are we on red? This part here, he cuts it out and throws it away. Okay, now, what was the original length of the card? The original length was what? 30. And how much did he cut off? X. So what's left then? If you started with 30, you cut off by X, how much you got left over?
30 minus X.
30 minus X. Lovely. So that will take you from here to here. Well, do we lose any of the height?
No.
No, the height was originally 15 and is still 15. It says here that this card is mathematically similar to the photo now. There's the photo. So let's work it out. Let's do a little rectangle here. Let's get a rectangle and just to represent that. Oh, that looks nice. Lovely. Right, this rectangle here represents what? Represents a photo from here. What is the measurement of the photo? 10 and 16. Now, this height of the photo is mathematically similar to the height of the card. Now, how does 10 become 15? You multiply by the scale factor. What is this? What is that scale factor? 1.5. Because 10 times by 1.5 is 15. So 10 times by 1.5 is equal to 15. That's my scale factor. Okay, now, if I multiply the height by 1.5, I have to also multiply the length by the same number, isn't it? So let's do this bit of working out over here on the side, because I'm running out of space over there at the bottom. Okay, let's go for a blue now. So what can we say? We can say now the width, the length, sorry, times by this scale factor, the same scale factor will give us that new length. So let's start over here somewhere. So we're going to say now 16, the original length of photo, times by the scale factor will give us the new length. The new length is what? 30 minus X. What did we say earlier what the scale factor was? 1.5. So 16 times by 1.5 is equal to 30 minus X. Now what is 16 times by 1.5 first of all?
24.
That will give you 24.
24.
Right.
Okay. Okay, so 30 minus a number is equal to 24. 30 minus what number gives you 24?
26.
You mean 6?
6.
Okay, 30 minus the number 6 will give you 24. If you wanted to do this more kind of like a algebraic in terms of the method, you want to solve for x, make x the subject, we move the minus x to this side. The 24 we move it to that side. What do we get now? We get
30.
positive x now because with minus we didn't like the minus.
So would it be 30 plus 24?
30 minus 24. Yeah. So x will give us a value of 6. So the answer to that question number 20 is 6. Well done, folks. Well done.
Do you not need to write centimetres or do you have to leave it 6?
Okay, let's have a look. It says to us work out the.
It just says value.
Okay, so yes, we should definitely put down centimeter because x is a length. Yes, if it's scale factor, just the number. Thank you for that, Prataba. Right, let's move on to the next question. Okay.
End of the lesson.
Huh?
End of the lesson.
Is it?
Yeah.
Okay, let's have a look. Okay, we actually are reaching towards the end of the lesson. Right, just give me a second while we. Okay, folks, welcome back. Students have gone home. It's time for me to finish up this video by myself. Okay, B, C, and D are points on the circumference of a circle center O. So we're talking about B, C, and D. It says ABE and ADF are tangents to the circle. Now, special rules for tangents. What do we say about tangents? We say that a tangent, say for example, if I just call it here, and I just slightly offset it to show you this is the tangent that they're talking about. So whenever a tangent touches a radius, okay, let's change to a blue now. Okay, no, I didn't want that one to change straight away. Back to red. Okay, let's whoa. Let's undo that one and let's get a blue one. So this is our radius when it touches the tangent, it always meets at 90. Oops. Whoops. Okay, right. Now let's go back to our pen mode. So let's put our right angles in here. Oh, right angle. So the shape A, B, O, D. So let's write that. Let's write some of that down. So we said first of all. So we say right over here. A tangent always meets a radius at a right angle. So therefore, this angle, if you want to define it, ODA. So therefore, angle ODE is equal to this angle here, which is, for example, ABO. Angle ABO, which is equal to 90. So given the mathematical definition, we will write down the angle. So we know that now that this is 90. We know now that this is 90. Now, if you look at the shape, here, let's change color once more. We know that the shape A, B, O, D is a quadrilateral. So we say here angle sum of a quadrilateral ABOD is always 360 degrees. So angle sum, so the inside angles, so we can work out now quite easily. We can work out this angle here. Therefore, so we can say angle DOB, which is that one here, is equal to what we got 360 minus all the angles that we know. So we're going to start crashing into things. 360 degrees minus 90 minus 90 minus the 40. Therefore, the angle of, oops. Oh. Okay, all right. Let's just try to undo the last bit. Angle DOB, looks like we're starting here, is equal to 360 degrees minus 90 minus the other 90 minus the 40. So minus these three angles, that gives us that one. So what we're doing really is 360 minus, well, 90 and 90, that will give you 180, and 180 plus the 40, 180 plus 40 will give you 220, so 360 minus, that will give you 100 and, oops, sorry, I'm about to write the answer down. The answer is 140, that should be here, sorry, pardon me. I'm working ahead of myself. 120. Okay, let's just get the rubber and tidy that up a bit. It looks a little bit messy. Let's make it nice. Pardon me, I was running ahead of myself there. So that's 140. So this angle here is 140. If this angle here is 140, then we can quite easily work out that question that we've been given. Angle O. We've been asked to work out angle ODC. Okay. We can work at the angle then. Let's work at the angle. Let's change color now. So what do we have here? We have the situation here with the angle which an arc subtends at the center. So we say the angle. Oh, what do we have? We don't want green. Okay. Let's do that. So we can say here angle DCB is equal to, what's it equal to? It's equal to 70 degrees. Why is angle DCB equal to 70 degrees? And we now going to give the mathematical proof, the reason for that. So we say the angle which an arc subtends at the center of a circle is twice that subtended that it subtends, right? You will leave a rubber there. That it subtends at the circumference. So what he's saying is that this angle here, 140, is double of that, so that's about 70. Now we can, our target for the question is we need to work an angle ODC, which is we have to work out this angle here, the yellow one. This angle here we need to work out. Okay, now what do we know? So we know quite a bit of this triangle's coming together. Okay, no, I don't want that one, on purple. So 90, 75 angles at a point add up to 180. So this angle in here is going to be what? So 90 at 75, so we have another 15 here. So we have to now make a point on that. So we say here angles at a point on a straight line. Oops. A straight line add up to 180 degrees. Therefore, OBC, angle OBC is equal to 180 minus 90 minus 75, which is equal to 15 degrees. So we've defined them, we've got 15 from here. That's 15. Now, what about this angle here? Well, these two add up to 360. That's a nice easy one. So let's change color again. So we can say now here, angles at a point O add up to 360 degrees. Therefore, angle DOB. Angle DOB is equal to 360 degrees minus what we just worked out earlier, which was 140. So 360 minus 140, that will give us 220 degrees. So now we know that. So we know now that is 220 degrees. So we know these three angles here, 1, 2, 3, we can work out the missing angle. That's the last part of the jigsaw. Okay, right, let's have a different color. So what do we say now? We can say the angle, oh, that's not a nice color, it's 2. Okay, okay. What do we say next? Full stop. So the angle sum of a quadrilateral. There's another quadrilateral here, this one here. Angle sum of a quadrilateral. Oh. Is 360. Which quadrilateral we're talking about? BCDO. BCDO. That's what I'm talking about. That's 360. Therefore, the angle that we're looking for, ODC, angle ODC is equal to what? Is equal to 360 degrees minus 220 minus 15 minus 70, and that will give us the answer. So that will give us a total of, so the missing angle is 55 degrees. If you work that out, that is what it should give us. Okay, I know for us that question was quite long-winded, but we need to give the mathematical proof for all the different steps of our question. Okay, let's move on to the next questions now. Let's move across a bit the page. Let's make it a bit bigger. Across, whoop, a bit too much across. Whoa, that's better. It's looking nicer. Right, I made it nice and big on purpose. Let's have a look. Let's just copy out again over here. 3x squared, y to the power of 4, all of this to the power of 3. Now, normally we're used to having, for example, just one item to the power of another item, so raising y to the 4 to the power of 3. Here we got 1, 2, 3 items. So we have now 3 items. First, second, and third item all going to be raised to the power of 3. Remembering that the 3 has a little invisible power of 1. So what that means is this, 3 to the power of 1, multiply that by 3. We have x squared, we're going to raise that to the power of 3, so we're going to multiply the powers together. And y to the power of 4, times that by 3 as well. Okay, now 1 times by 3 is 3, 3 to the power of 3. 2 times by 3 is 6. 4 times by 3 is, oops. Okay, what I meant is, okay, 6. And 4 times by 3 will give you 12. Now, just to finish it all off and bring it all together, 3 to the power of, that will give you 27, x6, y12. And that is the end of our part A. Lovely. Let's move it down a bit now. We have much more space for the next part of the question, which is a nice, lovely question here. Give it a full screen there. So we have x squared minus 9. Now this is a special type of question. This is called the difference of two squares, because x squared, that's a square number, and minus 9, which is 3 squared in disguise. So we can rewrite that as x squared minus 3 squared. Now, when you have this special type of situation, x squared minus 3 squared, it simplifies in a very lovely, easy way. We have x minus 3, which is x minus 3. We replicate the brackets and put a plus in there. So when you have a squared minus b squared, it factorizes as a minus b, brackets, and a plus b as that. So that is a very special way that this kind of difference of two squares factorizes. Now the bottom part here, we are looking for two numbers that multiply to give you minus 3. Okay, let's have a look. So the factors of minus 3, what are they? So minus 3 is made up of minus 1 times by 3, plus 3, or plus 1 times by minus 3. Okay. Now, we need to split this up here. Okay, let's use a different color. So when you factorize this, you get 2x. So when you split 2x squared, it's going to be 2x and x. 2 is a prime number, so it splits in that way. Now, we need to get a plus 5. So to get a plus 5, most likely we're looking at the numbers here. We are not going to be using the minus 3 one. We're going to be using this one here, because we've got a plus 3 in there. We need to put the plus 3 opposite of 2x. Why? Because that'll give you 6x. And then you put the minus 1 opposite the x here. So that'll give you the plus 5x. So this will then regenerate this. So this actually is here. And we copy it over here now. And as you can see, that we can now, we're in a situation where we can cancel. So x minus 3 times by x plus 3 divided by 2x minus 1 times by x plus 3. So the x plus 3 happens twice, so they can cancel them each other out because you're dividing top and bottom by x plus 3. That leaves you behind with x minus 3 on the top. We don't need the brackets anymore because there's no more multiply outside. And we don't need the bracket at the bottom either, and that gives us 2x minus 1, and that is the final answer for that part D. Okay, right, let's move on. Okay, let's end the question number 22. Let's make the screen a bit smaller so we can see where we are. Whoa, that looks lovely. Okie dokie, right, let's move forward. Okay, question number 23, one of my lovely questions, 23, 24. Yummy, yummy. We got a probability and vectors. I hope you love vectors and probability. I'm trying to make them nice and easy for you, as easy as possible. Okay, let's start labeling this up. Yvonne has 10 tulip bulbs in the bag. 7 tulip bulbs will grow into red tulips. 3 of them will grow into yellow tulips. So straight away, this will be 3 out of 10, 7 out of 10, 3 out of 10. Yvonne takes a random 2 tulip bulbs from the bag. She plants the bulbs. Complete the probability tree diagram. Now, if you look at this particular question here, what we have to realize is we got now 10 bulbs, but if we take 2 out, it says she takes 2 out from the bag, obviously the one followed by the second one. So this question, even though they haven't mentioned it, is a question that involves without replacement. So what's going to happen is in the second go, when we take, this is taking the first red bulb out, when we take the second red bulb out, there won't be 10 bulbs left anymore. There'll be only 6 of them. 7 red becomes 6 red. The 10 total becomes 9 because you removed 1. So that's 6, 9. That automatically will have to become 3 9s. Okay, so this one, if you pick a yellow bulb first time, you will have 9 bulbs left over, out of which 2 of them will now be yellow, and the remaining said this will be 7 red ones. So the probability on the second part of the second part of the tree diagram will change because you have removed 1. It depends on the previous one. So it's dependent. Now, it says to complete the probability tree diagram, which we have completed. Work out the probability that at least one of the bulbs. Now, this language here, at least one of the bulbs will grow into a yellow tulip. Now, the best way to think of this, look at an analogy. In the morning, you're having breakfast. Your mom says to you, how many toasts would you like? You say to your mom, I would like to have at least 1 toast. So you have to think, what does that mean? What does your mom make? That means she makes 1 toast, 2, 3, or 4, or anything more than 1. At least 1 means there should be 1 or more toasts. So in this case, at least one of the bulbs is yellow, which means one of them should be yellow or both of them should be yellow. So let's have a look at which particular possibilities will give us where there's 1 or 2 yellows. So we can either, if we start on the red one first, we can either select a red first, followed by a yellow. That's got 1 yellow in it. So that's probability of a red and probability of a yellow, and there's the yellow, the one. Or we could have a yellow first, followed by a red. Probability of yellow and the probability of a red. So here's our 1 yellow. Or we could get a 1 yellow followed by another yellow. Probability of yellow and probability of yellow. So here we have at least 1 and then we have the extra 1. Okay, so let's see how we work that out. So we need to work out these probabilities. Remember, the and represents in probability we change it for a multiply. Okay, now is actually this probability or this one, and the word or in mathematics means plus. So it's this or this one or this one. So now let's start doing some numbers behind this. Okay, so probability of the red was 7/10, and means time. Probability of the yellow was 3 9s. Probability of the yellow was 3/10 and then 7 9s. Probability of yellow and yellow, which here is going to be 3/10, and means time, 2 9s. Okay, we need to work all these calculations out. So that will give you what? We can do some cancelling, but at the moment all the fractions would be nice if we left it. So 7 times by 3 will give you 21 over 90. 3/10 times by 7 9, that will give you also, whoops, put equal sign in there, I nearly forgot that. Whoops. Let's delete that. Start again. When in doubt, start again. 21 over 90, and that will give you 6 over 90. So it's nice and easy for us to add. So this is all the chances that we can remember. It's all this and all this. So either this event or that event, and all means plus. So what do we have? We have 21 over 90, or another 21 over 90, or a 6 over 90. These are the three possibilities that will give us at least one yellow. So we have 21 plus 21 plus 6, that's 21, that's 42. 42 plus 6 is 48 over 90 is our answer. Okay, so we can cancel that down if you want to, but I'm just going to leave it here, and the examiner's mark scheme has got that as the answer, so that's good enough for me. Okay, lovely, lovely. Right, let's have a look at the next question. Question number 24. Just going to have a little break. Okay, folks, right, let's back. Question 24, let's start next to it. Okay, OAB is a triangle. You can see the OAB. M is the midpoint, and that's very important. So let's use this particular little line here, a nice red. If O to M is the vector M, and M is the midpoint, that means this length here, MA, is the same length as here. So the vector O to M is repeated. So I'll put that down here like that. Okay, and it says similarly, N is the midpoint of this line OB. So if halfway the vector is called N, then if you do the other half vector, it will also be N. Okay, well, let's get rid of the point. Let's go back to pen. So this vector here will also be called M. And this vector here will be the same as the first one, which will also be called N. So the first one is M, that one's M. This one's N, that one's N. So we got all the vectors covered. Hope you can see that this is vector N and that one's M. Okay. If you want, actually, what I'll do now, I'll just quickly go over those vectors in the red again. Let's put the line thing back on. Here. Done. So, oh, I didn't mean to do that. Okay, let's undo that. Okay, lovely. Let's get back to our pen mode. It says here O to M, so we know what this is. Show the AB is parallel to MN. So let's change color here. Let's go for an orange and let's go for a straight line. So we'll go from here to here. Okay, we have to show that MN is parallel to AB. So I've just slightly put it to one side so you can see it clearly. Oh, maybe move it a bit. Okay, that's lovely, that'll do. Let's get back to our pen. Yummy, yummy. Right, okay, let's go back to blue. Okay, so we have here this vector here. So we have to show that these two are parallel. Show the AB. So AB we normally represent it like this. Normally A to B. This one M to N. We don't know what that's not a vector. That's just telling us what the direction is. We've got to work that out. So let's work out first of all A to B. So if I want to go from A to B, I've got to go the scenic route because we don't know the direct route. We've got to go A to O, then O to B. So we can say that first. So A to B is going to be equal to this way and then that way. A to O plus O to B. Now A to O is going to be, because we're going in the opposite direction of M, vectors are directional. As minus M and another minus M, that will give us minus 2M. That little line indicates that this is a vector. Okay, and then plus OB. Now OB is going to be an N vector and another N vector. So that will be plus 2N. That little line indicates that N is a vector. So that we've now worked out A to B. Underline that. We've got to work out M to N. Let's change color. No, not the blue. Okay. So let's have a look at M to N. So M to N, if I want to go from here to here, I can't go directly because we don't know the vector. We'll go on the scenic route. We'll go this way and then that way. This way and then that way. So M to N is equal to, first of all, M to O, that way, and then this way. Then O to N. So that's my idea. Now what is M2O? Well, M2O is the opposite vector to mine plus M. So M is going that way, we're going opposite direction of M, so M becomes minus M. Now we're going from O to N in the direction of N, but with the length of N, so we say plus N. Now, to show that our vector is parallel, first of all, what we need to do here, what we could do, we should really factorize this top vector here. Let's do that now. Let's do that in the black. So this vector here simplifies to minus 2 M plus N. Oh, okay. Now, if we look at Mn, that's minus M plus N. Okay, and that's minus 2M plus N. So this one is double of that one. So we can say, let's make a statement. So we make a statement now. Our statement is that AB, the vector AB is double the vector of M to N. So it's the same vector in a sense, but it's just twice the length. This is minus M, that's minus 2M. This is plus M, that's plus 2N. So this vector here, AB, is literally double. It's in the same direction. It's parallel to it, but it's just double the length. So let's have a look. So AB is equal to double of M to N. So we can say as AB is a multiple of Mn, AB is parallel to Mn, and that's the end of that one. Okay, folks, let's move on. We've got a few questions left, and I'm exhausted, and it's coming up to 10:15. Right, let's move on. Okay, right. We're nearly at the end. Okay, right, let's have a look at T, right? 25A, rationalize the denominator means. What does that mean? Rationalize the denominator means we need to get the bottom number, which is like at the moment currently is a third. Root 3 is a rational number, turn into a rational number like a whole number, for example, or a fraction. Now, to turn a third into a rational number, rationalize it, we multiply it by itself. And what we do to the bottom, we must then do to the top to keep the fraction balanced. So that'll give you 12 root 3 divided by root 3 times by root 3 it'll give you, well, it actually give you root 9. Okay, and root 9 is a square number. Root 9 will give you an answer 3. You can either say a root multiplied by itself will give you the number inside, which you can go from here straight to there. Or we just say root 3 times by root 3 can be simplified as root 9, that becomes 3. Now remember, the reason why I said that was, okay, let's get that, we've got a nice red there. Okay, let's see if I can pull this one off. Okay, yeah, yummy. Okay, whoa, I didn't want to do that. Okay, 9 is the square number, put a square on it, so that gives you 3. Now, what else can we do? Can we do any more cancelling? We should be able to do some more cancelling. Divide the, whoops, excuse me, I forgot to set that function off. Let's get back to the pen. Okay, now, lovely, that's better. Okay, let's go for the green now. So, divide the bottom by 3, divide the top by 3 is called simplifying. So the final answer is going to be 4 times by root 3, which will give us 4 root 3. Because we look at the values of root 2 plus root 8 squared. What that means is this bracket, you must multiply it by itself. So let's do that then. So we have to do root 2 plus root 8 multiplied by itself, root 2 plus root 8. So what we do now, we need to multiply. That's the way we multiply normally, double brackets, FOIL. Front 2, outside 2, inside 2, and last 2. Whoops, I don't want to do that. And last 2. So root 2 times by root 2. Let's just actually write it down. So we have root 2 times by root 2. Root 2 times by root 8. Root 2 times by root 8. Remember, it's plus root 8. I will leave that for the moment. Just but it's root 2 times by plus root 8. And then we have root 8 plus root 8 multiplied by root 2. Then we have plus root 8 times by, oops, I meant plus, times by another positive root 8. Now let's simplify all of this, see what that gives us. So when you multiply a surd by itself or a root by root, it gives you the number inside. Or you can say root 2 times by root 2 is root 4, and the square root of 4 is 2. Now root 2 times by root 8, again, when you simplify a surd and multiplying, you can pull them under one square root sign. So that gets simplified to root 16. Now root 8 times by root 2, that will give you again plus root 16. And here actually we should have wrote down here, there's also plus. Because this item, then because when you multiply them, we are then adding the items. Okay? Yeah. Well, when I say adding, I mean the sign of this plus root 2 times by plus root 8 gives you plus root 16. That way I mean that instead. Now you have plus root 8 times by plus root 8 gives you plus root 64. Now, what do we realize by these numbers inside? Now, what we realize is this. Number 16. Oops, and I forgot the sir and said I'll put that in a second. Pardon me, folks. I'll put that in one moment. Give me a moment. Okay, right. Let's get back our pen. I missed something out. Apologies, folks. Apologies. So we have here like that. That's better. Okay, now the reason why I've boxed around the 16, 64 is because 16 is a square number. So put a square around it. 16 is square number 64. So we can simplify these. They will simplify. What will they simplify to? So root 16, what's the square root of 16? Is going to be 4. So 2 at 4. Square root of 16, another 4. Square root of 64 is 8. So we should have here 2 at 4 at 4 at 8. That will give us an answer of 18. I hope that's helped, folks, with your understanding of this particular question. Okay, let's just measure we. Okay, lovely. I think we're on the last question now, and I'm exhausted. Okay, I'm sure this is the last question of the paper. How to drink my tea? The diagram shows part of a sketch of the curve y equals sine x or sin x right on the coordinates of point P. Now we should know. Okay, let's get rid of the black. Let's go for a nice bright orange. That the amplitude of a sine curve is 1 and the minimum of a sine cube is 1 here. Okay. Now when I said amplitude earlier, I meant like the peak, the highest point is 1 and the lowest point 1. So please pardon me for that small error in language. So the maximum value is 1 and the minimum value is 1. Now this is one complete sine, what's the word I'm looking for? That is one cycle. Now it goes from 0 normally to 360. So that point is there, 360. That's halfway point, which is 180. So it's asking us now here for write down the coordinates of point P. Well, point P is nice and simply 180 along the x-axis, and it has a height of 0. Okay. Now let's have a look at the next point. It goes work out the coordinates of Q. Now if that's 180, half between 180 and 360 will give you a value of 270. Because think about it, we are going up in 90s. That's 90, add another 90, add another 90, add another 90. That gives you 360 altogether. Let's get rid of those squiggles now. Okay, let's put that back in. That's 270. So we can say the value of Q will be 270 along the x and come down by the minimum value, which will be then give you -1. Okay, the next one. Okay, I think this is the next one and the last one. Okay. Whoa, yes, yummy. Let's end of the question. End of the paper. Here's a sketch of the curve y equals a cos bx plus c. This particular function has got all the different things you could do to it, done to it. We have squeezed it by a factor of the b. we have enlarged along the y-axis by a factor of a, and then we moved up by a factor by the plus c. Now, if you first of all look for some clues, the amplitude was, so say amplitude, the maximum displacement between -3 and 1 is 4. If it's 4, that means if you were to come do a little sketch of it, so that means 2 would be above and 2 would be below it. That's how I get 4. It's just been moved up. So we know that really the graph started really at 2 and down to -2. So that tells us here that the graph has moved up by 1. So the plus c value to answer first, it is 1. So originally the graph was drawn like this, down to -2. So that line that is quite lame, that line that is drawn there. Okay, so if we have displacement of 2 to -2, so it'll be from here to here. Originally it's been moved up by 1. So the -2 value became -1 and the 2 became 3. So we can see where that came from. That's the C value. That last value there tells you how much you move the graph up or down by. So that's the easiest one to detect in a sense. Next. Okay, this B tells you how many times the cycle is repeated within a normal cycle. Now, normally we said before, if you look at our sine function, from here to here, that is 360 degrees. So this half and that half. Now, if you look at here, so from here, okay, it's actually now, normally it would be, this is a cos function. Oops, I've drawn this, pardon me, I've drawn the sine function by mistake. Apologies, folks. Let me scribble this out for you. Let's start again. That one. Okay, here we go. That's the normal cos function from 0 to 360 over here. Now, so normally from here to here is normally one cycle. And that's another cycle. Okay. And that's 360 there. So we've got 1, 2, 3. We got 3 cosine. We got 3 cycles squeezed into 1. That 3 is represented by the B. That tells you how many times you've got the original cycle that goes from 0 to 360 in the same space as 360. So as we said here, from here is one cycle, from here is the second cycle, and third cycle. We managed to squeeze 3 cycles of 360 into space of 360. So the B value is 3. Next, your A value is your multiply, tells us how much we are stretching the graph in the y-axis direction. So going back to the original point here, oops, I think I've drawn, pardon me again, apologies, a mistake here. That should have been drawn as a cos curve instead. Apologies there, folks. So it should be really like this. That should have been 2 and -2, my demonstration earlier that I was trying to make. So, and we said it moved up by 1. So for example, okay, grab the whole thing. That's not what I wanted to do. Now, if you look at our original function, our original cos function doesn't go from 2 to -2. It goes from, oops, I'm trying to do something about it's right, let's see if I can. Okay, sorry for my, oh, that's just wrong. Okay, let's rub that off. Oh, okay, let's do it over here. Okay, right, I don't want to do that. Normally, we go from 1 to -1 on a cos function. This has now gone from 2 to -2 before we modified and moved it up. So to get from 1 to 2, the scale factor has been multiplied is 2. So that is where that value comes in. That's 2, that's 3, and that's 1. That's 2 tells you how much you stretched it this way by a factor of 2. This 3 tells you how much you squeezed the function in. So within the space of 360, you manage to get 3 cycles in. This 1 means you move the whole graph up by 1. So that's what those 3 numbers are telling us. So the A value, last but not least, is being stretched by a factor of 2. And that is the end of the paper, folks, and I'm shattered. Okay, folks, there's still a few questions I have to do here, possibly using the visualizer or using some other technique and put them in later. The ones which were involved a bit more technical skills using software and things. Forgive me for that, I haven't been able to do that yet. I'm going to put this together now and upload it. Okay, let's stop it. So